Hello everyone, we're the Noob team. Here's our final project presentation with the aim of doing mosaic image recognition. Face recognition is a prominent biometric technique for identity authentication and has been widely used in many areas. Challenges of doing face recognition arises when many real-world images are likely to suffer from low resolution or have mosaic effects. This leads to difficulty of doing face recognition applications. We propose our network to do face recognition on mosaic images with the aim of doing super resolution. Super resolution defined as recovering a high resolution photo from a low resolution photo by artificially interpolating the unknown pixels. Our work proposed a novel approach that consists of two parts. First, super resolution on mosaic images. Second, face recognition on the recovered images. For part one, we have implemented a ResNet plus UNet, and a generative adversarial network from photorealistic single image super resolution as a baseline. With this baseline, we tried two different approaches to make improvements with a pre-trained mobile net. For part two, we would do face image classification with a pre-trained mobile net. The dataset we're using is from homework 2 part 2 in this course, which contains a few thousand images of label IDs. The overall dataset size is 3.2 gigabytes with about 820 images, which contains 2,300 distinct labels. Each image size has 32 times 32 pixels, with an average size of 1 KB. We did our pre-processing on this sample dataset to get all images corresponding mosaic images. As shown in the slides, similar to typical deep learning problems, our pipeline includes pre-process, train, classify, evaluate, and analyze steps. For the most interesting part, training, we tried two different approaches, ResNet plus UNet and super resolution GAN. For ResNet plus UNet, this approach can be divided into two parts. First, use a ResNet to generate a super resolution image from a mosaic image by first reducing the image dimension and then increasing the image dimension back to 32 times 32. The intuition to use this combination is that UNet is known for segmenting medical images, and the ResNet has already been used to do super resolution. UNet would use a shortcut to transmit the feature back when the layer contains the same dimension as the previous one. We have utilized both MSE loss and perceptual loss during training. The perceptual loss here is a pre-trained ResNet face classifier. Super resolution GAN consists of two parts, generator and discriminator. The generator can produce a super resolution image with the input as a mosaic image. The discriminator can discriminate the produced super resolution mosaic image from its corresponding original image. To make improvements from this baseline, one approach we tried is to pre-train a model and use it as a feature extractor to help us calculate content loss. One of the greatest obstacles is when initially using MSE loss, it inherently blurs the facial texture. By applying a pre-trained mobile net to extract the face features, instead of simply applying MSE loss, we use this model to calculate the loss between the extracted feature of the super resolution mosaic image and the extracted feature of the original image. We expect such feature extractor can bring improvements which can handle images which has an overly smooth texture. Overall, as we have the ground truth label of each image or faces label, and we pre-train a mobile net model to do face image classification. After we finished our training to super resolution on our image, we'll try to see whether the super resolution in mosaic image can be classified to its corresponding ground truth label. The overall performance is shown in classification accuracy. Here are some results from two different models mentioned previously. Our produced image can only contain some high-level detail regarding the image, but cannot recover the image details. Besides model tuning, we believe one of the most possible limitations implemented in this network is not yet optimized for the small image size. Also, our mosaic technique is to pick a random pixel around the 5 times 5 pixel areas and blur all surrounding pixels at the same color. This can be a problem as well. For super resolution GAN, another reason is that our pre-trained mobile net, which is used for feature extraction, cannot perform perfectly as it only has around 73% prediction accuracy. Regarding the accuracy perspective, the performance is relatively low at this point. Overall, we try two different approaches to build the super resolution pipeline using UNet plus ResNet and super resolution GAN. Both can achieve a reasonable same performance as ResNet with L2 reported in the previous paperwork. Thank you.